I'm going to do two more examples from page 137, examples 2 and 3, just so if anyone needs a little extra support on this, we have a couple more examples. So I said that this is page 137, and we're going to do example 2 first. So just like in the previous problem, we're going to follow those same steps. My first step is to label by circling each term in the expression. So in this expression, I've got this first term, which is 35x y to the power of 4. We have another term that's negative 14x to the power of 4 y squared z. And then our third term, which is 56x cubed y cubed z cubed. So just like the last problem, we have 3 terms. So when I factor it out, I need to factor out something that is in common with all 3. So first, I'm going to factor each term. So 35x y to the power of 4, 35 can be divided by 5 and 7. So this ends up being 5 times 7 times x times y times y times y times y. The first term has been factored. So now we're going to go on to the second term. My second term has a negative number at the beginning, so it's just really important to remember that. So when I'm factoring this 14, it's really a negative 14 I'm factoring, so I can't forget that negative 1. And then we have our 2 and our 7. So this is negative 1 times 2 times 7 times x times x times x times x times y times y times z. So that one's a little bit longer. And then our last term is 56x cubed y cubed z cubed. So I'm going to factor my 56. 56 is an even number, so it's divisible by 2. 56 divided by 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. So I get 2 times 2 times 2 times 7 times x times x times x times y times y times y times z times z times z. My next step is to identify the factors we have in common. So just like we did on our first problem, we're going to look to see one factor at a time if it's in common with all 3. So my first number I'm going to look at is 5. 5 is not in my second term, so I'm just going to skip it. 7, 7, and 7. So I can circle my 7s. I've got an x, another x, and another x, so that's a good one. We've got a y, and a y. We have another y, and y. If I look for a third y, my second term does not have a third y, so we can't use any more of the factors to get the greatest common factor. So I'm going on to my next step. We're going to write the expressions for the remaining non-common factors. So what you're looking at is the numbers you did not circle. So our first term, we had 5y and y left, which gives me 5y squared. Our second term, we have a negative 1, a 2, 3 x's, and a z. So that ends up being negative 2x cubed z. And then for our third term, we have 2 times 2 times 2 times x times y times z times z times z. So that ends up being 8x squared y z cubed. And then I'm going to write this as a product. So I know that I need to use my greatest common factor. And so my greatest common factor, we said, was 7 times x times y, which is just 7xy squared. So then my final answer has that on the outside. And then what is on the inside is our remaining expressions. So 5y squared minus 2x cubed z plus 8x squared y z cubed. So I know these steps are long and can feel tedious, but following them one step at a time allows us to not make silly mistakes. Okay, just like most math problems, factoring expressions by the greatest common factor can also be phrased as a word problem. So, example 3 on page 137 says the polynomial 15x squared minus 3x represents the area of a rectangular garden plot in square yards, where the length of the garden is equal to the greatest common factor. Determine expressions for the length and width of the garden. All this is asking me to do is factor this expression. I'm just going to draw a rectangle so that we can maybe visualize it a little bit more. Our area is 15x squared minus 3x, and I know that the length of the garden is equal to the greatest common factor, which means that our width is going to be whatever's left over after taking out the greatest common factor. So just like I did on the previous problems, my first step is going to be to label each term in the expression. So I've got 15x squared and negative 3x. So I have two terms here, and I'm going to do exactly what I did before. We're going to write out the prime factorization of each term. So we have 15x squared, which becomes 3 times 5 times x times x. We have negative 3x, which just ends up being negative 1 times 3 times x. I'm going to identify the common factors. We have 3 in both and an x in both. So my greatest common factor is 3 times x, which is just 3x. I need to not forget about what's left over. So in my first term, what was left over is 5x. In my second term, all that was left over was our negative 1. So the way that I'm going to write this expression is a product of the GCF and the remaining terms. Remember that we can check our answer by factoring this out if we would like. So let's just make sure that when we distribute, we're going to do 3x times 5x, which is 15x squared. 3x times negative 1, which is negative 3x. And that's the same exact expression that I had at the beginning, so my factorization is right. I know that the length of my garden is the greatest common factor, so our length is 3x, and our width is what's in our parentheses. It's what was left over, which is 5x minus 1. So that's our answer.